Good day. In this video, I will discuss some of the PT problem fourth pass listen.
For number 1, capacitor, an electric resistance heater, and an impedance are connected in parallel to a 120 volt 60 Hz system. The capacitor draws 50 var, the heater draws 100 watts, and the impedance coil draws 269 volt ampere at a power factor of 0.74 lagging. Determine the system power factor. As we can see, we have three given loads: the capacitor, the heater, and the impedance. In getting the power factor, first, we will use the principle of conservation of AC power. ST equal S1 plus S2 plus S3 and so on, where our S is the complex power. The total complex power for S1 is our complex power for capacitor, and the S2 complex power for the heater, S3 for the complex power of impedance. First, the complex power for capacitor, the given is 50 var. VAR is our Q, or the imaginary part from the capacitor. Since it is capacitor, we will put negative sign, and since it is imaginary, we will put J. Now for our complex capacitor, it is equal to negative J50 volt ampere. For the complex heater, the given is 100 volt ampere. There is no reactance given, so 100 plus J0 is equals to 100 volt ampere. For complex power for our impedance, the given is 269 VA. To get the angle, the given power factor is 0.74. We will use the formula cos theta equals 0.74, and then equate the formula theta equals cos raised to negative 1, 0.74. Now, theta is equal to 42.27 degrees lagging. Since it is positive, it is lagging. Now, our complex power for the impedance is 269 bar angle 42.27 volt ampere. Now we have the three complex power. We will add them up. Total complex power is now equal to negative J50 VA plus 100 VA plus 269 bar angle 42.27 volt ampere. The rectangular form is 299.0555 plus J130.9362 VA. And we will convert it to its polar form. Now our total complex power is now equal to 326.4636 bar angle 23.6454 degrees volt ampere. That is for our complex power. To get our power factor, we will use its angle, and using this formula, cos 23.6454 is equal to 0.9160 lagging. Since it is a positive angle, it is lagging. Next, for number 2, a given load takes 40 kilovolts ampere at 50% lagging power factor, while another load connected in parallel across the same source takes 80 kilovolts ampere at 86.7% lagging power factor. Find the apparent power. The given is 40 kilovolts ampere at 50%. As we can see, the lagging power factor given here is in percent, and we will convert it to decimal. As we can see, 50% will become 0.5 and 86.7% will become 0.867 power factor. Since it is both positive, it is lagging. Now, we will find the apparent power. The solution is the same as like in number 1. The total complex power is equal to S1 plus S2 and so on. Since we have the 2 given, S1 is equal to 40 for its real part. And to get the angle, we will use the power factor in decimal using this formula. Theta equals cos raised to negative 1 times 0.5 is now equal to 60 degrees. Next, for our S2, 80 kVA is our real part, and to get the angle, we will use the 0.867 power factor and use the formula theta equals cos raised to negative 1 times 0.867. It is now equal to 29.8881 degrees. Now we have S1 equals 40 bar angle 60 degrees kVA and S2 equals 80 bar angle 29.881 kVA. And now to get the total complex power, we will add them up. 40 bar angle 60 degrees plus 80 bar angle 29.881 degrees. Its rectangular form is equal to 89.36 plus J 74.5056 kVA. Its polar form is 116.3456 bar angle 39.8203 degrees kVA. Since we are finding its apparent power is only the magnitude of the complex power. Since this is the magnitude of the complex power and it is the apparent power. Now, our apparent power is 116.3456 kVA. Next, for number 3, a 250 kilovolt ampere 0.5 lagging power factor load is connected in parallel to a 180 watt 0.8 leading power factor load and to a 300 volt ampere and 100 var inductive load. Determine the total apparent power in kVA. We have a given 250 kilovolt ampere at 0.5 power factor lagging, means it is positive for its angle, and 180 watts at 0.8 power factor leading, means it is negative in terms of its angle, and 300 volt ampere with 100 var inductive load. We will find the total apparent power in kVA. First, for our complex power S1 equals 250 bar angle 60 degrees. 60 degrees came from theta 1 cos raised to negative 1 times 0.5, the 0.5 power factor lagging. So, our theta is positive 60 degrees. Now for our S2, it is equal to 225 bar angle negative 36.8699. First, our theta is equal to cos raised to negative 1, 0.8, and it is equal to 36.8699 leading. Leading means it is negative. Now for our magnitude, we have a given power, the 180 watts, and we have the formula P equals S cos theta. We will find the complex power. Complex power S equals P over cos theta is now equal to 180 over 0.8, because cos theta, cos 36.8699 is just equal to our 0.8. Now 180 over 0.8 is equal to 225 VA. Now, our S2 is equal to 225 bar angle negative 36.8699. Now, for our S3 equals 282.8427 plus J100 VA. As we can see, we have a given 300 VA with 100 var inductive load. Since it is inductive, we will use the Pythagorean theorem or the power triangle. Q equals square root of S squared minus P squared. Since we have the given Q, the 100 var, we will equate the formula. P equals square root of S squared minus Q squared is now equal to square root of 300 squared minus 100 squared. P is now equal to 282.8427 watts. Now, our S3 is 282.8427 for the real part plus J100 for the imaginary part. Since we are finding the apparent power, we will sum them up. 250 bar angle 60 degrees plus 225 bar angle negative 36.8699 degrees plus 282.8427 plus J100 is now equal to its rectangular form 125,462.8427 plus J 216,471.3509. For its polar form, it is equal to 250,201.4601 bar angle 59.9042 degrees VA. Since we are finding its apparent power in kilovolts ampere, we will convert it in kilo form. 250.2015 bar angle 59.9042 kVA. Since it is apparent power, we will get its magnitude only. Our apparent power is now equal to 250.2015 kVA. In number 4, a 440 volt 60 Hz generator supplies two parallel connected loads A and B. Load A draws an apparent power of 100 kV ampere at 0.8 power factor lagging, and load B draws an apparent power of 70 kV ampere at unity power factor. Determine the kVAR supplied by the generator. We have the given loads A and B. For the complex power for load A, 100 kV ampere bar angle 36.8699 degrees. 36.8699 degrees came from the formula theta equals cos raised to negative 1, 0.80 equals 36.8699 degrees. For the complex power for load B, 70 bar angle 0 kVA came from, since unity is equals to 1, our formula is theta B cos raised to negative 1 of 1 equals 0. So for our complex power for load B is 70 bar angle 0 degrees kVA. To get the kVAR, we will sum up the two given loads. The total complex power is equals to 100 bar angle 36.8699 plus 70 bar angle 0. The rectangular form is equal to 149.999 plus J60 kVA or 150 plus J60 kVA. The value of our Q in this generator is equals to 60 kVAR. Since the generator supplies energy, therefore, our Q for the generator is equals to negative 60 kVAR.